Hey guys, welcome back. We're going to be using machine learning in image classification with this data set right here. However, if you guys want to apply my code to a different data set, which I'll show you how, feel free. If you guys, I'm also going to be talking about convolutional neural networks, which I have 20 videos about that. With AI in medicine, even beauty detection with binary classification. What degree a woman is beautiful or average looking? See my other video. All the data sets are on Kaggle or on my GitHub. I've got AI image classification as well, and I've got all kinds of machine learning as well on my channel. Not just deep learning or SageMaker pipelines, which I got that with AI too, with medical treatment prediction models. See some of my other videos or AI with pharmaceutical data. I've got that too with SageMaker pipelines, and I got that with Streamlit to make it a web app. I've even got basic machine learning on my like this. I mean, we're going to be using it for machine learning. We're going to be using it for this data set. Anyways, guys, 60 files in the test, right? Hold on, just to show you. And then we got 340 for the train. Hold on, let me refresh it just to show you guys. We got 340 for the train. Anyways, guys, I also never showed substance on my channel, and we're only going to be using the train folder. If you guys want to add to the project and add the other 60 and combine into the training folder to make it more samples to train on, feel free if you guys know how to do that. We're going to also be talking a little bit about AI in medicine, why it is used, even though it's a little unrelated. I just forgot to cover it in my other videos for AI in medicine with convolutional neural networks. It established patient trust. Also, RCNNs, which I have one video for that also with video data. It catches things doctors might miss with colonoscopies, mammogram imagery, even with images, not just cameras. So, anyways, check out my other video, convolutional neural networks to establish patient trust. And for machine learning, it also for machine learning, you can use it for treatment classification, whether a patient will benefit, have a neutral, or negative effect from the treatment. Either serving predictions like a machine learning engineer and doing ML ops for many tabular data frames. Um, that's used too. Or just as a data scientist with less of a load on your notebook, whatever. Although a lot of data scientists also these days do a machine learning engineer's job, they just have the title. Every company is different. You guys will learn that also. Some have ML ops engineers and they do mostly everything. Some have data scientists who do everything, the team. And then there's the data engineers for the data pipeline only. Some data scientists do everything, and some machine learning engineers with that title do everything, including going to get it from the data lake and creating data sets. It's all, yeah. And I meant streaming data pipeline, not the data pipeline in the ML ops pipeline. That's a different kind of pipeline. That word is thrown out there these days. Anyways, guys, let's get down to it. Import these libraries: NumPy is scientific computing, pandas for data manipulation, which we're going to be doing. Also, guys, one more thing. The data directory, like I talked about, we're using the train folder. And also adults and children. Remember the two classes, image size 100 And let's make it. Create the training data with this code right here, and we're going to have to append it. Remember when you guys do this function? Resize it, just like on my convolutional neural networks, you resize the array on a different index when serving a prediction. See my other videos for that. All my convolutional neural networks, it's not just training. We predict images and we compute it. Like we do NP argmax for multi-class class label. We do NP rounds for computing a binary label. And then different degrees if you didn't want to use the NP round function, a percent to each class. Also, guys, the CV2 IM read, we use CV2 also for training and machine learning also when we deal with image data. This is just to generate an image, nothing special. Now, one more thing, see my image processing videos for taking it and putting it on the grayscale and face detection to get rid of this blue. See my and adding filters. Yes, you can do this with your own images if you guys want. And I'll show you how on my image processing one. Print the len with the Python on the training data. There we have it. Okay, the len of the image. X and Y, append. Reshape with NumPy. It's a very useful tool for scientific computing. Okay, on this index of -1. Hold on. And then we're going to use the test train split function from scikit-learn. If you guys want to use a different test size, you guys can feel free. The reason why I like the naive Bayes classifier on tabular data, and then in this case the image data, it's often less biased, less quickly when it the truth is all models in production will become biased, whether they're stale from being unused or they're serving so many predictions they end up being bogus and it's learning wrong because you haven't been hypertuning the parameters. Either way, naive Bayes, if it's often your best classifier for training, it's often you're often safe with it in production, meaning not as many hyperparameter tunings are needed. A lot of other models become biased quickly. Like they train really good, then when it comes to production, they're making predictions like even I know that can't be real, and I'm not, that profession that I'm serving the prediction for. Like if it's medical, I'm no doctor, but I know that ain't right. Well, or so many of these aren't right. That's an example. Naive Bayes is often your best bet with scikit-learn. Also, guys, SageMaker Pipeline, see my other videos for that, hyperparameter tunings for them as well. And MLOps for model drift, serving predictions as well. Predict, model X test, because we got to cross validate, remember? And guys, just so you guys know, when you guys are in the real world, this is, or you guys are in the real world, but you're going to deal with non-technical people, and it's a classification model. They want to know how it's performing. A confusion matrix is the best tool we can use, the true and the predicted. You guys see, to show them how it's doing when we cross-validate. Okay? They often understand in finance. Anyways, guys, the conf this is how we cross-validate. And this is how we visualize it right here. See some of my other videos for more in depth on visualizing. All my classification videos, I pretty much do this. Anyways, guys, I hope you learned from my video, and also I would like to cover some more things. Check out my reinforcement learning video. Reinforcement learning is being used in the medical industry as well. Yeah, they're starting to. Not just self-driving stuff. Speaking of which, see my OpenAI gym for self-driving and reinforcement learning for trading, which if you want to get more advanced to that, go off on your own. Make a model that automates stock trading, which happens sometimes. You guys see? Based on data, we can use reinforcement learning to create a reinforcement learning training model, but that's an RL agents. This is machine learning, a different branch. although that one has TensorFlow. Also, guys, see a lot of my other videos. If you're here already, there's something you need. I got something for everything. So check out my channel. Feel free. Also, guys, feel free to share with anyone who might need this, might like it. You know, you'd be helping them out, you'd be helping me out. Check out, I've got over 130 videos. Anyways, guys, leave a comment letting me know what video you guys might want next. I'm here for you guys also. And I haven't forgotten about the guy with the RL Agent SageMaker video. Yeah, I will do that when I get more support, and then I create another AWS account to do that what he wanted. Now, I've got every other SageMaker pipeline video, and I've got tons of Streamlit apps, including content-based recommendation systems. I've got ML language detection apps also. I've got a lot of neural translation machines. I've even got LSTMs, which I got two in my previous video, and then one more in depth for doing it with that data set. My last video was telling you how you could do it with your own sales data, how you could do feature engineering on it, and then create forecasts, basically. Anyways, guys, uh, like I said, I'm going to get back on the cloud eventually. Before, my videos were more on the machine learning engineering side. Now they're on the data scientist side. I got to be more well rounded because somewhere there's a compromise for tasks that are needed when there's contracts and you guys are, trying to do contract work. A lot of the times now, the clients are looking for guys who are more on the machine learning engineering, the technical side, who are more focused on getting the models approved for production rather than building the models like data scientists. Anyways, guys, these videos, check out. There's something you need. I got basic and advanced. This is more basic intermediate. Anyways, guys, I hope you like my video. Stay tuned. Hit like if you liked it. Subscribe if you haven't already. And stay tuned. This channel's going to get more diverse as we go. By the way, this is pretty hard to find, and you guys can apply this to your own data set if you guys want. Use another algorithm, improve it, build on it. Don't just simply copy. Understand it and make it your own. You guys see? And you guys can by changing that right here, your own algorithm, different parameters you might pass. There's all kinds of stuff you can do. Changing the size. Anyways, guys, I hope you like my video. Stay tuned. Bye.